Let me introduce you to Xamarin. The Xamarin story is actually a very long story, and it's very interesting too. And it's interesting that it actually came to this point where we can take advantage of these technologies. The history of Xamarin actually started back in the 1980s, and probably before that. You could probably relate it to everything in computer science, right? But kind of the real roots of this thing started with a person named Anders Heilsberg, and he was working at Borland, and he had developed the Delphi language. The Delphi language was I believe it was based off of Turbo Pascal and the work that he had done on that. Microsoft hired him in basically 1996 to start working on J++, and that language didn't really go anywhere, but it kind of laid the foundations for .NET. And .NET ended up being a huge bet that Microsoft made on the idea of a virtual machine and virtualizing programming languages. And in 2000, they started working on the C# project. And Anders was the original architect and continues to be the architect of it to this day. So he's been working on this for 14 years almost. And interestingly enough, they released .NET in 2002, and he's still working on things now, different languages other than C# like TypeScript, which is a superset of JavaScript. So back when they were originally building this idea of .NET, Microsoft was very committed to building things in a standardized way and standardizing the work that they did. So there's this association out of Europe called ECMA. ECMA was founded in 1961, and they hold basically the standard for C#, CLI, which is the Common Language Infrastructure, ECMAScript, which is basically another version of JavaScript that was kind of a competing version of JavaScript, and continues to be supported by some browsers. JSON, which is a universal data structure that we know and we use all the time now. And they hold quite a few more standards. So Microsoft, when they were originally working on C#, decided that they were going to publish the C# specification to ECMA to be standardized. Along with that, they also published the CLI, which stands for the Common Language Infrastructure. The Common Language Infrastructure is basically really at the core of .NET. There's the Common Language Runtime and the Common Language Infrastructure. The Common Language Infrastructure allows for multiple languages to be built on this .NET framework, but it's completely standardized. It's not specific to Windows. It happens to be developed by Microsoft. They're putting the most investment into it, and they basically built this out, and it became the .NET framework, and it supports multiple languages, including C#. So that became a published standard in 2001, and every time a new version of C# or the Common Language Infrastructure continues to evolve, they continue to work with ECMA to publish those specifications and standardize them so that everybody could take advantage of them and they could port them to whatever platforms they want. So this person, his name's Miguel de Casa. He was working in Linux, working on some projects related to the genome and IRQ, and he's a brilliant developer, architect. He decided that he really liked the direction that Anders and Microsoft were going with C# and this idea of .NET. He basically decided to open an open source project to develop the ability to build a .NET framework and run C# on Linux and across all platforms. He created this project called Mono. The Mono project ended up getting a little bit of legs, and he teamed up with another person named Nat Friedman. Nat had like the designer-oriented skills and the business-oriented skills, and Miguel was just incredibly technical, incredibly sharp. They combined together and they created a company called Ximian. Ximian then was bought by Novell, and Novell basically continued to fund that project for, I think it was 8 years. They funded the Mono project for 8 years, and they continued to develop and make progress on it. And they actually released it, and I'll show you in the next slide here kind of what the progress of that has been. When Attachmate bought Novell and stopped the Mono project, Miguel was able to take full rights to all of the intellectual property that they had developed around Mono and created the company called Xamarin. And on top of Xamarin is where they have built out the functionality to support Android and iOS and other platforms. So it makes it really a universal, makes C# portable across all platforms. So Mono is basically C# and the .NET implementation. If you just look at this history, it started in 2001, it was released in 2004, and it supported the C# 1.0. And then in 2009, they released Mono Touch, which is basically was what they call now Xamarin.iOS. So Mono Touch was Xamarin Mono for the iPhone. In 2011, they released Mono for Android, which is the same thing. It lets Mono basically run on Android and continue to compile C# to run natively on Android devices. They also developed a Mono developed IDE, and they have a Mono Mac project. So this basically allows you to do, and Xamarin.Mac allows you to build applications for the Mac and the Mac App Store that are built in C# and can share all of this code. So why are we excited about Xamarin? Why is kind of the market in general for enterprise apps for these devices so excited about the introduction of Xamarin? Well, many enterprise organizations use C#. If they don't use it exclusively, they have at least some projects that are developed in C#. And if you're a Java developer, C# is very natural. And it's a very modern language, so it's more advanced and more capable in terms of the functionality than that you can get with even like Objective-C, because Objective-C is more of a legacy language that continues to live on. C# has some more elegance to it, in my opinion, but I'm sure that can be argued by many. So some of the reasons for Xamarin: apps are native, and performance is native, because we're not an HTML5 app working against a JavaScript library and having to kind of deal with the browser and all of that config. No, we're working against the native controls that are built into all the native kits. App kits and store kit, event kit, iCloud, Play services, compatibility libraries, all that stuff. It's all native. It's just a layer that sits on top of it that basically does the interpretation between what we can call in C# as kind of a managed .NET library, almost like not a .NET, it's a Mono library. It's kind of hard to differentiate the two, but what we can call as a native C# call, and that's mapped to the actual call in the native SDKs. So you can basically get native performance, and you can use all the native controls. You can do everything you can do with these native languages and these native development kits in Mono and in Xamarin. So you can share C# across iOS, Android, Windows, WinPhone, Mac, and Mac apps. So that means you can have a core library, and then all you're really programming that is unique to those devices are the user interfaces. And that's the stuff that you want to be native anyway. That's the stuff that you want people to have the native experience, because they're familiar with those devices and those UI patterns. And you want to work with designers that understand those platforms, and then you want to be able to develop those native, but you want to share everything else. You don't need to rewrite the communication stack or the business logic or data access or any of these other things. You can share it. And I'll show you in a minute what we mean. We believe that the user experience is a big seller for why we'd use Xamarin, because we can do these native UIs, performance, and the features. And we're not sold on HTML5 apps being the answer for the mainstream, broader consumer applications, because especially the cross-platform applications, because you just can't do everything. You can't take advantage of all of the capabilities of the UI and the way that a user expects them to be there. They always feel just a little different, and sometimes they're great, but for many apps, it's not good enough. And the proof in that is the Facebook apps. Facebook was originally developing their apps as HTML5 apps within a cross-platform type of library, and they moved completely away from that, and they're building everything native. And I would argue that they should have chose Xamarin, because they can do everything with native performance and they can get the cross-platform benefits. So how does it work? So this diagram here shows that what a typical Windows application looks like. You've got Windows as your platform, .NET as your runtime, and then you're going to build out layers of an applications, and you're going to develop them in C#, and then as a native Windows application these days you can use XAML to use a WPF app, and then you'll have the logic written in C#, and then you'll have a bunch of libraries that become your business logic. Well, with Xamarin, they allow you to go even more portable with that C# language. So if you look at this stack here, you still have .NET for the Windows Phone and Windows, and they're using XAML for their presentation layers. But you can now add with Mono and the Mono runtime, you can compile C# across all of these devices, and you can take advantage of the native ways that you develop UI for those devices. So here's an example of Mac using Zib and storyboards on iOS, and Android has the XML interface, and there's this shared code that can go across all of them. So you're minimizing the maintenance of these applications longer term, and you can share, because you can share so much. You can share 50, and in some cases all the way up to 80-90% of the code. And there's other libraries and stuff that can make that process much simpler to get that code reuse as you get more experience with the platform. So there's a couple of different development environments. There is a development environment for the Mac, and I'll show that to you. There's also two options on Windows. There's one, a native Xamarin Studio, and then there's also Xamarin Business Edition that's plugged into Visual Studio, so you can develop in Visual Studio and take advantage of everything like ReSharper and all of these other kind of add-ins that come with Visual Studio. And you can develop against your Android, not your Android in Visual Studio, but also the iOS application in Visual Studio. And you can still do debugging, and I'll show you that as well. So the way that the whole interaction between Visual Studio and Windows works is you're actually running on a Mac. So you have the Mac that is the main host machine. You run a virtual machine. I run Parallels. I have Windows and Visual Studio running in Parallels, and it does. And Xamarin's installed on both machines. It'll start to then remote the communication between Xamarin.iOS on Windows to the Mac OS, and the emulator is what actually runs on the Mac OS, or the deployment to the device happens on the Mac OS. So I'm going to show you some examples of what I'm talking about here. So let's start with Xamarin Studio here, for example. This is Xamarin Studio, and you can see here that I've got a simple project here. I've got one solution. Inside of this, I've got a core library, and the core library has the things that are completely reusable across both user interfaces, like data access and data models and view models and business logic and all these types of things. And I've got an Android project and an iOS project. So I'm going to start with Android to show you an example of this app running here on the Mac. So I hit execute, and it's going to start up the emulator, and it's going to then push those changes to the emulator. And then it should pop up here in just a moment. So here it is. I then can, within Android, go into this application. It's called the Field Service application. It's on GitHub. It's a really great reference app if you want to learn. And as it logs in, you'll notice I've got a very native experience. So it's a list app. It's an app that's supposed to be designed for dealing with field service calls where a customer can go in and accept, or someone like a salesperson or service person can go in and accept. So I get all these kind of native behaviors that I would expect in Android. It's kind of a little weird with the emulator right now. Then click on, for example, confirmations. I can go in and add a signature. Now, here's another nice example. There's a component store. Xamarin's kind of built this idea of components, so you can pull down things like this signature pad. Somebody else already wrote it. I just plug it in, and I can take advantage of it. Huge time savings there, instead of having to write this stuff myself or try to find examples. And then if I hit save, I'm getting full debugging support in Xamarin Studio. So this is basically saying, I want to add this to this model. I want to add the image, here's the signature view, get the image, get it in black and white, turn it into a byte array, and if I step over that, then I can come in here and I can look at, I can go through and debug. I'm waiting for my little fly over here. I can, I want to add a watch here. Usually it just pops up as a little, oh, you have to take my word that it basically will pop up. I can do full debugging. There it goes. It's just taking a second. And I can go through and I can debug everything. I can go all the way down to the bytes that were in that signature pad. So, you know, it's a very rich debugging experience. And so you can do this same type of development for Android and iOS. And so, like, for example, if I'm in iOS and this is all on the Mac at this stage, and I want to edit the storyboard, I just double click the storyboard, and what it'll do is it'll actually pop up Xcode. And Xcode then will load the storyboard. I can make changes to the storyboard, save them, and Xamarin will detect that save. And it will basically then allow me to make changes to it. And so what's neat about this stuff is that, again, it's just an abstraction of the native controls and the native coding constructs and objects. So for example, base controller inherits from a UI view controller. If I go to the definition of UI view controller, you can see it's just mapping the UI view controller. And these are all, this is the same object model you have in UIKit. So I can do all the same programming, all the same event handling, everything that I'd be able to do is available through the object model. I'm just writing the code in C#, and I can take advantage of async await, and I can take advantage of link, and I can take advantage of all the features of C#. I'm just coding against a different API. Now I'm going to flip over to Windows, and I want to pop up here the same solution running in Visual Studio. And so you can see here that I've got the field service app. Again, it's the same core library. I've got Android, I've got iOS. And if I want to then go here and run this project, I want to compile it again here. Start this project. And you'll notice down here in the corner it says remote building. So it's building it, and then it's pushing the code over to iOS, and then it finishes the build there, deploys it to the application, sets up a debug session, and then it will basically push me over to here to run in the iOS simulator. So if I type in admin, and I want to go into this same example here, and then drop down into confirmations, or I want to go horizontal, then I can go here, add signature, and again I'm adding a signature, hit save, and you'll notice now it's going to take a second here because of the remote server, but I can get the full debug. Oh, it looks like I had a connection issue here. Let me try it one more time. So this is kind of like sometimes the downside of this is you've got to set up this communication. If you have a networking issue or something, it can cause a little problem with your debug session. So you basically have to tee it up so it knows the IP of the machine. So it could be like a Mac Mini, but in this case I'm just doing it on my Mac, which is the host. So I'm going to try it one more time here. So waiting for it here. Here we go. Let's see if I can get the debug to work. Signature, save, back here in Visual Studio, debugging. I can go and continue to step through it just like I would anything else. And now I can go over here and work through the object model. So again, that's the exact same type of call here. There it is, there's the byte array, and here's all the properties of the signature object. So very powerful. Right, and you can You can get the best of C#, you can get the best of native applications, native performance. You can work with designers who want to take advantage of every feature of the native platform. You can do it with this Xamarin technology, and you get this added benefit of code sharing, less maintenance, one solution with multiple projects. So that's why we're pretty excited about it, and we're having a lot of fun ramping up. We committed, we became a premier partner with Xamarin just because we think we're making a bet that they've got kind of the right model.